So now we will be taking different cases, or you can say different problems, that how to find this angle theta, how to find the pressure at any point in this accelerated vessel condition. Will the pressure will be same or it will be different, the ways, how many ways are there to find the pressure, and what volume will flow out if we will accelerate this vessel. So these are some of the questions. Also, how to find the force on these side walls. So these are some of the questions which arises. So we will be covering all of this A to Z. So first of all, let us try to find out what will be angle theta. So first we will be solving it by the normal method which is given in each and every book. You can follow it. So I am solving it by that method. Then we will be applying our the method that I have told you in earlier videos. We will be applying that method only. So let us consider 2 points, point 1 and point 2, at same level. We are actually finding angle theta. This is our first aim. Okay, consider 2 points on the same level. The first point is actually a height h1 below from the surface of water, and this means the inclined surface of water, and this point 2 is actually a height h2 from surface of water. Okay, now join these 2 points. The distance between these 2 points is L. Now we will be moving along this direction, or we will be applying Pascal equation along vertical direction to find the pressure at this point. Then we will be doing the same thing with this point, finding the pressure at this point, and we will be finding the pressure again by traveling along this point as well, because in this case there is acceleration in this direction as well. First of all, make the vessel at rest before doing anything. So we will be making the vessel at rest. What we will do, we will just reverse the direction of acceleration and observe in the frame of vessel. So that's why I was telling you that if we will observe in the frame of vessel, it will be much easier. So here is the water, or here is the water column like this, and we have reversed the direction of acceleration, which means that we are in the frame of vessel, and also a gravity is acting downwards. So now let's find the pressure at this point. I am making it again. This is 1 and this is 2. This is h1, this was h1 below and this was h2 below, and the distance between these 2 points were L. Now acceleration is along this direction. We have reversed the direction because we are now observing in frame of reference of vessel. Vessel is at rest now. So now we can easily find the pressure since we are now in vessel's frame. So let's find the pressure 1 by traveling along this direction. First we will be traveling along this direction. So pressure 1 will be P0 plus rho g h1. I think it's simple to write it, because here only gravitation, acceleration due to gravity exists, and this perpendicular acceleration doesn't contribute along this path. Means when we will travel along this path, it doesn't contribute for the acceleration. Similarly, we will be writing the pressure at this point 2 by traveling vertically again, P0 plus rho g h2. Now here are our two equations. We will be utilizing them as well. Now since there is an acceleration along horizontal direction as well, so we will be traveling from this point to this point, or we will be applying Pascal's law along this direction as well this time. And I haven't mentioned one more point, then that I have told you in my first video as well, that along the direction of acceleration, acceleration is acting like this. So along the direction of acceleration, the pressure increases. Same with the acceleration due to gravity. We have already seen it that along the direction of gravity, acceleration due to gravity, pressure increases. The pressure is more at this point and as compared to this point. Similarly, the pressure at point P1 will be more than P2. So actually we will be writing P1 is equals to, here the pressure is P2 plus rho. Now acceleration here is in this direction is A and this distance is L. So P2 plus rho AL. This is our third equation. Okay. If you are not able to understand this, just reverse this just to be more easier so that you can understand it. Just reverse it. So what you will see like the water surface like this, acceleration is acting like this, and gravity, though its gravity always acts points downward, but we have just to understand, we have just reversed the water column. And now this situation, here were our points P1 and P2 and this distance was L. So this situation is similar to vertical variation of pressure, means where the acceleration, where we take acceleration due to gravity. So like this only we have applied this equation. By following this, we have applied this equation that P1 is equals to P2 plus rho A. So from all these three equations, from this first and second equation, we will be finding P1 minus P2, that will be rho g H1 minus H2. And from this third equation as well, we will be taking P2 here, P1 minus P2 is equals to rho AL. Now from these two equations, we will be equating both of them and we will be getting AL is equals to G H1 minus H2. Rho will cancel out from both sides, and from here A by G is equals to H1 minus H2 upon L. So this is one of the important relations, that H1 minus H2 divided by L is actually the ratio of accelerations in the horizontal and vertical direction, A divided by G. So question is not over yet, we have to find angle theta actually. So these were our 2 points. This was surface of water like this. This was point 1 and point 2. And this was the distance was L. This was H1 and this was H2. We have to find actually the theta. So what we will be doing, consider this small triangle. This is small triangle. So in this small triangle, you can clearly make out that this small length will be H1 minus H2. H1 minus H2, and this distance was L as usual. Now this if this is theta, this will also be theta by corresponding angles. So in this triangle, tan theta is equals to H1 minus H2 upon L. So from earlier situation, we have H1 minus H2 upon L is equals to A by G, and from both of these equations, equation 4th and equation 5th, from 4th and 5th, we have tan theta is equals to A by G. So theta is actually tan inverse A by G, which is quite amazing, and in general it is quite observable as well, that theta actually is the ratio of A by G, means it's the ratio of horizontal and vertical acceleration. It doesn't depend of any, it is independent of any height, means H1 and H2, it doesn't depend on that, it's just the ratio of acceleration. So whatever the acceleration you give it in horizontal direction, to find the angle theta, you just have to take the ratio of the horizontal acceleration. This was our horizontal acceleration, means the acceleration along x direction, and this was the acceleration along y direction, means theta in general will be tan inverse ax divided by ay. Just remember it, it is very useful.